A student made this conjecture and found two examples to support it. The conjecture is, if a rational number is not an integer, then the square root of the rational number is irrational. And for example, the square root of 3.6 is irrational, and the square root of 1/2 is irrational. Provide an example of a non-integer rational number that shows that the conjecture is false. So we have several examples of non-integer rational numbers. We have A, 4.5, B, 0.25, C, 9.62, and D, 2.1. And if we want to pick one of those non-integer rational numbers to show the conjecture is false, we need to take the square root of those numbers and see which ones would be a rational number still. So we would want to try the square root of 4.5. The square root of 0.25, the square root of 9.62, the square root of 2.1. And we want to see which of those radicands, which of those now numbers underneath the square root, which of those non-integer rational numbers are perfect squares. What times what, or what number times itself would equal the number underneath. That would make it a rational square root. And out of all our choices, the only one that works with is choice B. The square root of 0.25 is equal to 0.5. If you do 0.5 squared, you get the answer of 0.25. You get that non-integer rational number. And now taking the square root of 0.25, you get a rational number of 0.5. So this is an example that's proving his conjecture is false. So that makes our answer choice B.